Hi, kids. All right, you guys should have completed the parallel circuit, and you guys also did that homework about the analogy, so you guys should have seen the difference between a parallel circuit and a series circuit. So I will be talking about you guys. I want to go over the parallel circuit rules with you right now. So be sure you guys do put this in your notes because obviously this is going to be important when we're doing parallel circuits. But so this is our parallel rules, and dude, parallel rules. Anyway, so first of all, parallel circuits, by definition, they have more than one path for current. Okay, there's more than one way for the current to go around. If I draw my real quick parallel circuit down here, you can see that the current comes out, gets to this point, and then it can either go this way or it can go this way to get around. So again, it's always going from the positive side to the negative side, but it can go this way or it can go this way. So there are two paths for the current to flow. So there's more than one path for the current to flow. Because there's more than one path for current to flow, if you remove a light bulb, the circuit stays complete. Okay? Because there's more than one path, if you remove one light bulb, well, if I take this away, goodbye light bulb. Look, I still have a complete circuit. Okay? And you guys should have seen that in the lab. That was kind of repetitive. Sorry, there is a reason for it being so repetitive because there's certain things I'm trying to get across to you guys. More than one path. If you complete a circuit, let's make this back. Okay. If with a parallel circuit that the voltage the voltage always stays the same in a given circuit. Okay. Remember, guys, voltage is always measured across. So, for example, let's say I have 5 volts across my battery here. The voltage from this point to this point, from those 2 points, is 5 volts. The voltage from there to my finger is still 5 volts. The voltage from there to there is still 5 volts. The voltage from there to there is 5 volts. So the voltage in a parallel circuit always stays the same. So if I wanted to, I could say the total voltage equals the voltage for voltage 1 equals 2 equals 3 and so on. Okay? So voltage always stays the same for a parallel circuit. If I'm going to erase this, so hopefully we have this down. Okay, with a parallel circuit, the current, the total current adds up. The total current, I guess, is the sum of the individual ones. Is the sum of the individual currents. Okay, this should also make sense, guys, because if you take a look, let's say that I have my circuit here and I have 1 amp flowing here and I have 2 amps flowing there. Well then, how much do I have to have total going into the battery? Yeah, you guessed it, I have to have 3 amps, so this would have to be 3 amps. So the total current adds up to the individual currents. If I wanted to write this, I could say I for current equals I1 plus I2 plus I3 and so on. Let me get rid of this. Okay. The next thing we want to talk about is, well, what happens if we add resistors? So in a parallel circuit, if you add resistors, Okay? In a parallel circuit, if you add resistors, what happens is that the total current goes up and the total resistance goes down. So if you add resistors, the total current increases, okay, and the total resistance decreases. Now this is weird, okay, because series circuits are pretty straightforward. Because if you add a resistor, the total resistance goes up, the current goes down. That kind of makes sense. But with the parallel circuit, if I add more resistors, you need to think, geez, I'm adding another path. If I add another path, that's going to make it easier for the current to flow. So if I add more resistors, my total resistance goes down. If it's easier for the current to flow, I'm going to get more total current, so my total current goes up. My favorite analogy for this, guys, is that people analogy where they're leaving the auditorium. If you add doors like they are normally in parallel, one next to another, more doors you add, the easier it is for people to get out, and the more people can get out, so the higher the current. Whereas if you were to somehow add doors in series, I don't know why you do that. You open a door, and then you have to open another door, and then that as you add more doors, the total current is going to decrease, total resistance is going to go up. But hopefully this does make sense, that the total, if you add resistors, that happens. And if I was to put this in an equation, and this one, you guys are just going to have to take my word for it, but it does work, that the equation is 1 over RT equals 1 over R1 plus 1 over R2 and so on, 1 over R3. Dot, 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 dot. Okay? And we'll practice using all of these equations in just a minute. But hopefully that makes sense. Bye, kids.